Hello, I'm Nanix, and this is part 1 of the Let's Make a Survivor tutorial series. In this part, we'll be implementing the new Unity input system and using the event paradigm to move our character with a Rigidbody controller. This tutorial has been performed in Unity 6 using the Universal Render pipeline. To begin, we're going to remove the tutorial assets that come with the project, deleting the input system's actions that comes by default, and then creating a quick scene. A cube for the ground, 25 on the X, 25 on the Z, down 0.5 to put it below the grid, an empty for the player, to which we will add a Rigidbody component and a capsule collider, setting the constraints to freeze on the X and the Z, and freeze position on the Y, as we don't want it rotating on the Z or the X there, and we don't want it moving on the Y. We do need to lift that capsule collider up a little bit though, so that it sits flush on the ground, and then we can add the visual elements by creating a folder essentially, which is an empty, and then adding a capsule, which we'll call body, and we'll set that to 0.75 high on the Y and move it up 0.75. Removing the capsule collider as well, we'll duplicate that, call it eyes, make it 0.75, 0.2, 0.75, and whilst holding control, we will move it to the Z positive axis, as this is forward for the character. We'll add some quick materials here, just so that we can differentiate it a little better. Call this one body, duplicate it, call it eyes, and in the body we'll make it a nice blue. Then drag and drop on. Wonderful. We'll also set the camera up so that we can see the entire scene. We'll just put a rotation of 66 on it for now. Lift it up. Perfect. Okay, now we can begin. We'll create a folder called Input, within which we will create input actions, and we'll call this user input. The name is important. Before we do anything, we'll hit this generate C# class and apply. This will give us a C# class with all of the functions and access to them here. Double click this. We need to first create an action map. So we'll hit the plus here and we'll call this control. And then the actions, we'll call this first action locomotion, as we're doing movement. We need to set the action type to pass through. If we hover over here, we can see that pass through will not start and will never cancel, but it will create a perform action for every value change that happens. And that value is a vector2. Remove the default binding here, just by pressing delete, and then we want to add an up-down, left-right composite. We'll call this one WASD, and much as the name, we'll go through and you can hit listen and bind each key to each of the composite bindings. Now the cool part about the input system is, once we've done that, we can add as many others as we want. Say we have another up, down, left, right, and we want to call this left thumbstick for a gamepad. I don't have one plugged in, but we can find it by simply going left stick, up, and I'll fill this in quickly. Voila. Now you need to hit save asset so that everything regenerates. Now for the next step, we're going to create the handler, which will be of type scriptable object, and we'll call this user input handler. Open that up, ready to edit. To begin, we're going to create a small little interesting technique to gain access to a cached version of the user input class we've just generated. To do so, we'll use one variable and we'll set up a getter to grab the cached input But if it is null, we want to set it to a new user input class. This is the equivalent, right here, of doing this. Setting up a getter, and then checking if cached input is equal to null. Then set cached input equal to a new user input. And then returning cached input. So the shorthand is the 2 question marks and then equals to do all of this. Obviously, the use of the getter here comes from this here. There you go. Now we add an onEnable and an onDisable. And within here, we want to enable the input engine and disable it here, just to clean up after ourselves. The very next thing we need to do is register this file to take the callbacks from the user input. So that is input.control, which relates specifically to the action map we've set up here, .setCallbacks, which is a function that then identifies this script as handling the callbacks. You'll see there's a red squiggly line. That's because we need to implement the interface that this is expecting. As you can see, user input.iControlActions. We'll just add that up here, user input.iControlActions. And you'll note that control again is coming from the action map here. So within here, you can see that there is a function that needs to be implemented called onLocomotion. We can do that simply by right-clicking and hitting Implement Interface here. If your IDE does not handle that, then you just need to manually add it. Now we can prepare to create the public Unity actions. This one is expecting a vector2 that we will be consuming with our other scripts. So we'll call this locomotion. To explain the event paradigm that we'll be using this Unity action for, here is a little analogy. There is a small town with a bakery. The bakery sells special cakes on occasion. Mr. Paul goes every morning to the bakery to check to see if these special cakes are there, and every morning he leaves unsatisfied, until one morning he finds the cake. Mr. Event, his neighbor on the other hand, sits there listening to his radio. It broadcasts all the information from the bakery, and on that same fateful day, the bakery mentions over the radio that they have their special cakes in stock, so Mr. Event walks down only once and retrieves the cake. Both of them consume that cake, and it is delicious. Silly stories aside, the idea here is that Mr. Paul wastes all of that energy and resources by checking every day if the cake is available, whereas Mr. Event doesn't need to check. He is informed when it is available. And this is now a container that will have functions that are listening to it. So, when we come down here into the onLocomotion event, we need to set up a vector2, and we'll read that from the context, which is right here. A struct filled with data and functionality to access the information stored within. The key function we're looking for is readValue, and we're reading of type vector2. Now with that, we can set locomotion, question mark, similarly to up here, it's another shorthand, dot invoke. And we want to pass through input, because it's expecting, as we mentioned up here, a vector2. This here is the equivalent of going if locomotion is not equal to null, then locomotion.invoke input. It's just another shorthand that says, is there anything listening? What functions are in here listening to the locomotion delegate up here? If there are any, then I want to invoke input by passing through the argument. Now that we've done that, we can move on to the next step. Come back in here, create a scripts folder. But first, before we do anything, we do need to actually make the asset for that. So we'll go create scriptable objects, user input handler. And now you can see that we've got a user input handler asset. Within the scripts folder we've just created, we will add a new monobehavior script called player. Open that up, and within we don't need start or update, but we do need to grab reference by serializing a field of user input handler type called input. This just exposes the private variable to the inspector in the editor. Then we need to add an onEnable, an onDisable, not destroy, onDisable. Oh, it's not going to play nice with me, okay. And a new function called onMove, which expects a vector2 as the argument. Now that we have all this set up, we can start registering the functions to the Unity action that we've created in the user input handler. To do so, we go input.locomotion, which is the name of the Unity action up here, and then we want to use plus equals because we're adding a listener, and the listener we're adding is onMove. So this locomotion here becomes a container. We could add infinite extra if we had another function called onWalk. We'd all be listening for that locomotion. But we also need to make sure that we remove listeners when this script is disabled. Otherwise you can run into the issue of onMove running 5 times without disabling it. Awesome. Now within here, just to show that it's working, we're going to do debug log input. Let's head back over to the editor. On the player, we'll drag that script on, and then here where it says it's expecting a user input handler, we could drag from the project files, but because we've set it all up and typed it, it knows there's only one option available. If we now hit play, in the console we should see the vector2 that's coming from my WASD pressing. And yes, we can. We're seeing it immediately. The power of events. So now I'm going to create a variable here of vector3 called moveInput, and we'll set it by default to be vector3.0. Inside onMove, we want to set moveInput equal to a new vector3 with input.x on the x-axis, 0 on the y, and input.y on the z-axis. That is, forward and back is on the z-axis, which is up and down, and left and right is on the x-axis. Now let's create an extra function called move, which is going to handle the core movement of the character. Oh, if the IDE would stop playing silly buggers with me. Okay. Oh, fun. All right. First, we need to gain access to our current velocity, so we need to do a little bit of setup. We'll add another private variable of type Rigidbody called RB. We will add a private vector3 called goalVelocity, which will store our velocity over frames, and we'll add a few more serialized fields that are exposed to the editor. The first one being a float called moveSpeed, which we'll set to 12. Next, we want one called acceleration, also a float. I'll set that to 48 to make it snappy, and then we need a final one called acceleration max for limiting the total acceleration. We don't want it to go crazy and infinitely accelerate after all. Now, we need to get our current velocity, so vector3 current velocity, and we can do this by accessing the Rigidbody's linear velocity. Then we need to set our goal velocity, and we'll use the function vector3.moveTowards, which moves from one vector, in this case goal velocity, whatever it's set to, remember it starts at nothing, towards a velocity, so move input times move speed, at a maximum of the acceleration provided. So we want acceleration multiplied by time.fixedDelta_time, because this is a physics function. Now we have our goal velocity, we need to know what the velocity change should be that is applied to our rigid body. To do this, we will minus from goal velocity our current velocity. Then we'll grab that velocity change and we'll use the function vector3.scale, scaling velocity change as the A, and a new vector3 with 1 in the x, 0 in the y, and 1 in the z as b. This multiplies the first vector by the second vector, instantly removing any movement on the y-axis, because there should be none. If you recall, we don't want to move up or down. Finally, we need to then apply vector3 RB.clamp magnitude to this velocity change using acceleration max. This prevents the magnitude of this exceeding the max acceleration we've provided above. And as a last step, we then need to go RB.addForce, the velocity change, ensuring that we use force mode of type velocity change. We then need to add the fixed update loop. And within, call move. So every physics frame, it's going to move towards the goal velocity. Goal velocity is obviously set to move input times move speed. So if the player is not holding anything, that will be 0. Goal move to 0. If they're holding something, it'll move towards the goal. But before any of this, we actually need to register the rigid body. So in the awake function, we'll go rigid body equals get component rigid body, storing the component within the RB variable. Jump back over to the editor, and now we should just be able to hit play. And I'm moving left, I'm moving right, I'm moving forward, I'm moving backwards. Movement is working, but the character's not looking in their direction they're moving. Let's do that now. We'll add another function, this one called private void look. And within here, we want to grab the angle that the player is intending to move and then apply that to the rigid body's rotation. To begin, we'll add a gate, checking if move input is actually being pressed. So if it's equal to vector 3.0, that means no keys are currently being pressed, and we should return immediately. This stops the script from doing anything beyond this point. To get the rotation for the angle of the movement direction we're intending, we need to create a quaternion. And we'll call it rotate2, and we'll use the function quaternion.lookRotation for the move input. This converts a direction into a rotation. To then apply that, we need to adjust our current rotation. So we'll create another quaternion, this one called new rotation, and we'll use the function quaternion.rotateTowards. And this takes in the current rotation, or a from rotation, which would be rb.rotation. And we want it to rotate to. We need to add another variable up here, and we'll call this one rotate speed. And this will be in degrees per second. Whoop. So I'm going to set that to 360 degrees per second. Down here in our new rotation, we want to grab that rotate speed and multiply it by time.fixed delta time. So it will move a maximum of 360 over 1 second. Finally, we then need to apply this rotation by setting rb.moveRotation to the new rotation, and add that look function into our fixed update so that it's actually called. With that, we'll hop back over to the editor, ensure that we've got everything set up right, press play, and now when the character moves, you'll see that they start looking in the direction they're moving. And when I let go, they don't snap back to the front. They maintain the last direction that they were looking in. Wonderful. And with that, we are at the end of part 1. If you found this interesting and want to follow along, please subscribe to my channel. If you've got any questions, queries, or any feedback, please head down to the comments section and reach out. Thank you for watching.